Antibiotics are indispensable for the treatment of bacterial infections, such as life-threatening sepsis or pneumonia. They are also essential for protecting patients from the infections in the course of medical treatments, for example in the context of cancer therapies, organ transplantation or surgical interventions. These achievements are now in jeopardy. More and more bacterial pathogens are resistant to one or even several antibiotics. Infections with multi-resistant bacteria can only be treated with great effort or not at all. There is therefore an urgent need for new effective antibiotics. But in recent decades, the development of new drugs has stagnated. The initially successful approach of developing antibiotics under artificial laboratory conditions has been exhausted. This is where our National Center for Competence in Research AntiResist comes in. Bacteria in the patient tissues face entirely different conditions than in the laboratory and, accordingly, behave completely differently. Understanding these differences should reveal promising targets for new antibiotics. Our research approach begins and ends in the patient. This requires close collaboration between medical doctors and biologists. After tissue samples have been taken from infected patients, they are transferred from the hospital to the biological laboratory. There, they are analyzed using state-of-the-art, highly sensitive analytical methods. The results obtained are then used for the development of tissue culture models that simulate the conditions in the patient tissue as accurately as possible. Our investigations focus on 4 pathogens of global importance. Using specific biomarkers, suitable human tissue culture models are developed for each of these pathogens. These faithfully reproduce the infection process within the patient. In the next step, bioengineers further develop the tissue culture models established by the biologist along the specific needs of drug development. In this process, the models are miniaturized and parallelized. This will then allow automated screening of chemical libraries as a first step in drug discovery. Switzerland offers ideal conditions for this ambitious interdisciplinary research project. Basel plays a central role here. Physicians at the University Hospital, biologists at the Biozentrum of the University of Basel, and bioengineers at ETH Zurich are direct neighbors and can therefore collaborate closely. The implementation of the findings then takes place in direct interaction with small and medium-sized enterprises and globally operating pharmaceutical companies. Our project aims at triggering a paradigm shift in antibiotic research and development. We expect to discover fundamentally novel mechanisms and thus contribute to the development of truly innovative medicines.